All right, number 28, solve the system. And again, we have a system of three equations, three unknowns. Equation 1, x minus y plus 3z equals -4. Equation 2, 3x plus z equals 0. And equation 3, x plus 2y plus z equals 8. Let's notice right off the bat that equation 2 does not have a y variable. Notice in equation 1 and equation 3 we have a y variable, but here in equation 2 we do not. And because we don't have a y variable here in equation 2, let's go ahead and use equation 1 and 3 to eliminate the y variable from both of these equations. And to do that, we'll go ahead and use elimination just like we've been using in previous problems here on our practice test. So I'm going to go ahead, rewrite equation 1 and 3 so that we can take a better look and see what we need to multiply by to get rid of the y variable from these two equations. Well, we know with elimination, when we're eliminating a variable, we need the coefficient of that variable to be additive inverses of each other. So if we have a -1 here and a +2 here, let's go ahead and multiply this first equation by 2 so that we can get a -2 in front of this y, which will allow us to eliminate the y's from both equations. So we have 2 times x gives us 2x. 2 times -y is -2y. And so you can see now that we have additive inverses. These will eliminate. 2 times 3z will give us 6z. And lastly, 2 times -4 gives us -8. And so there we have two equations that will allow us to nicely eliminate our y's. So let's go through and do this. So we have x plus 2x gives us 3x. Positive 2y minus 2y, well, that goes away. We have z plus 6z gives us 7z. And here we have 8 minus 8 gives us 0. So now we have the new equation, 3x plus 7z equals 0. And notice now that we've eliminated the y from equation 1 and 3, let's go ahead and use equation 2. We'll bring it down here. We'll stack it underneath. And because both of these equations now are missing the y, we can go ahead and either solve for the x or the y, depending on what we want to do here. So let's go ahead and how about we solve for z? So if we're going to solve for z, that means we're going to eliminate the x. And to eliminate the x, because we have a positive 3x and a positive 3x, we can just go ahead and multiply this first equation here by -1. All that does is change the signs. So we have -3x. And -1 times +7 is -7. -1 times 0, well, that's just 0. And again, we can go ahead and add vertically now. So 3x minus 3x eliminates. Z minus 7z gives us -6z. And 0 plus 0 is still 0. And if we want to get z all by itself, we will divide by -6 on both sides, and that gives us z equals 0. All right, so we've solved for z. Now what we can do is take this z value, we can plug it back into the original equation number 2 here, where we see a z, and that will allow us to solve for x. So I'm going to go ahead and we've got z equals 0 up here, and I'm going to get rid of all this work. So if you need to copy it down or anything, go ahead and either pause or rewind the video. But I'm going to get rid of all of this because we've solved for z. And I'm going to take now equation 2, the original equation, 3x plus z equals 0. But now that we know what z is, I'm going to take this z out, and I'm going to plug in our z value, and we're saying z is 0. So instead of 3x plus z equals 0, we'll have 3x plus 0 equals 0, and we know that'll just go away, which leaves us with 3x equals 0. We want to solve for x, so let's divide by 3 on both sides, and that'll leave us with x equals 0. So x equals 0. All right, and now that we've solved for z and x, we can take those two values, plug them into either equation 1 or we can plug them into equation 3 here and solve for our missing y. So again, I'm going to go ahead and get rid of this work here. And it really doesn't matter which one we want to choose. I'll go ahead and choose number 3. We're solving for x, so we'll have x, or excuse me, we're not solving for x, we're solving for y, so we have x, right? So we're going to say 0 plus 2y plus z, but we now know z is 0. We'll plug that in, equals 8. Well, we know that 0 is going to go away, and that 0 is going to go away, so that leaves us with just 2y equals 8. And again, if we want to get y all by itself, we will divide by 2 on both sides, and that will leave us with y equals positive 4. All right, so y equals positive 4. Now what we're going to do is, I've mentioned in previous videos, we want to check to make sure our solution works for all 3 equations. And now that we've solved for all 3 variables, let's go ahead and write our solution as an ordered triple, right? So we're going to have our x, comma, y, comma, z. All right. Now we can plug these values into the variables for each equation to make sure this is in fact a solution to the system. Remember, this solution, this x, y, z, has to work in all 3 equations to be a solution to the system. If it doesn't work in all 3, then this is not correct. So let's go ahead and check ourselves to see if this works. So we'll check in equation 1 here. So x minus y plus 3z equals negative 4. Well, let's find out. So 0 minus 4 plus 3 times 0 equals negative 4. Well, let's see, that 0 goes away. 3 times 0 is just 0, so that goes away. So we're only left with negative 4 equals negative 4. So that is a true statement. So we know that the solution works in equation 1. Let's test equation 2. So we have 3x plus z equals 0. So we have 3 times 0 plus 0 equals 0. Well, 3 times 0 goes away plus z, or 0 goes away, so we're left with 0 equals 0. Again, that is true. So we know our solution works in the second equation. And lastly, let's test equation 3 here. We have x plus 2y plus z equals 8. We'll plug in our solution. So we have 0 plus 2 times 4 plus 0 equals 8. 0 goes away, 0 goes away. 2 times 4 is 8, so we have 8 equals 8. Again, that is true. So we know that our solution works in the third equation, and we can see that the solution works in all 3, and so we know the ordered triple 0, 4, 0 is the solution to number 28.